the universe is lying to us. It uses equations to tell us wormholes exist. Then, it uses the laws of physics to tell us they are useless. In 1935, the day Einstein solved the wormhole equation, he fell into a deep self-doubt. The solution was too perfect. It felt like a carefully designed trap. He told his student, Nathan Rosen, that the result was insane. Space-time could be punctured like a bedsheet. Two places 10 billion light-years apart could be linked by a bridge. Even crazier? Crossing this bridge would theoretically be instantaneous. Taking the normal route, however, would take light 10 billion years. This bridge became known as the Einstein-Rosen bridge, or simply a wormhole. But here is the terrifying part. It is mathematically flawless, yet physically impossible. It would collapse into a single point in a fraction of a blink 1/quintillionth of a second. Anything trying to cross would be instantly shredded into subatomic particles. Recently, a video of a Nobel laureate describing wormholes went viral. He mentioned that they might be created by highly advanced civilizations. Such civilizations might keep micro wormholes open by placing exotic matter in their throat. When he said wormholes couldn't form naturally, the comment section went wild. People claimed science ends in mysticism again. But have you ever wondered why an equation would yield something so bizarre? Why would the universe bury a back door in the laws of physics that we can never use? Is the wormhole a cosmic joke, or does it hide an ultimate secret? Let's answer the first question. Why do wormholes close instantly? It all comes down to the nature of space-time. Einstein taught us that space-time is not static. It is like an elastic rubber sheet. Place a bowling ball on it, and the sheet curves. That curve is gravity. The Earth makes a small dent. The Sun makes a large one. A black hole punches a hole right through it. A wormhole is even more extreme. It's like pinching two distant points of the sheet together and poking a hole through them. Theoretically perfect. But there's a fatal flaw. The rubber sheet has tension. The moment you let go, the hole snaps shut at nearly the speed of light. That is Planck time. It is trillions upon trillions of times faster than a human blink. Anything inside would be crushed into quantum fragments. In 1988, Nobel laureate Kip Thorne and his student Michael Morris published a shocking paper. They claimed they found a way. You need something called exotic matter to prop the wormhole open. How exotic? Its mass must be negative. To be clear, this is not antimatter. Antimatter still has positive mass, just an opposite charge. Exotic matter has true negative mass. If you push it, it doesn't move forward, it moves backward. It completely violates Newton's third law. Imagine pushing water with a stick, and instead of flowing away, the water surges toward you. That is the weirdness of negative mass. Thorne's team proved this matter could create anti-gravity. Instead of pulling space-time inward, it pushes it outward. This perfectly counters the wormhole's collapse. Sounds like magic, right? But it gets even stranger. In 1948, Dutch physicist Hendrik Casimir predicted that negative energy might actually exist. He proposed placing two uncharged metal plates extremely close together in a vacuum. The vacuum itself would push them together. Why? Because a vacuum isn't empty, it is filled with quantum fluctuations. Virtual particles constantly pop in and out of existence. Between the plates, the space is too narrow for long-wave virtual particles to fit. The energy density inside becomes lower than the energy outside. This creates a region of negative energy. In 1996, scientists at Los Alamos National Laboratory actually measured this force. It was equivalent to 1/30,000th the weight of an ant. This proved one thing: negative energy is not a fantasy, It is real. The Casimir effect thrilled physicists for years, but then reality hit them like a hammer. Guess how much negative energy is needed to keep a 1 centimeter wormhole open? The answer will make you question everything. You would need the mass of the entire solar system, and it must be negative. For context, the Sun alone makes up 99.86% of the solar system's mass. Now add Jupiter, Saturn, Earth, and every asteroid and comet. And how much negative energy does the Casimir effect produce? The density between those plates is only enough to open a hole the size of 1/quintillionth of an atomic nucleus. It's like trying to tunnel through the Himalayas with a single toothpick and expecting it to hold up the entire mountain. When NASA scientists ran the numbers, the conclusion was simple: despair. This discovery felt like a death sentence for wormholes. Negative energy exists, but the scale is off by astronomical margins. Humans will never collect that much exotic matter. Many physicists began to view wormholes like perpetual motion machines, theoretically legal, but practically impossible. But science is funny. Just when you think you've hit a dead end, a new path appears around the corner. In December 2022, the cover of Nature exploded. A team at Caltech, using Google's quantum computer, claimed to have created the first wormhole in history. Of course, it wasn't a physical hole in space-time. It was a quantum wormhole simulation. They created a pair of entangled qubits on a chip. They sent information into one side, and it emerged from the other. The information didn't travel through the space in between. This experiment was based on a bold hypothesis called ER equals EPR, proposed in 2013 by Leonard Susskind and Juan Maldacena. It suggests that wormholes, ER, and quantum entanglement, EPR, are two sides of the same coin. How radical is this? Quantum entanglement is what Einstein called spooky action at a distance. If a wormhole is just the geometric manifestation of entanglement, what does that mean? It means the essence of a wormhole might not be a gravity problem, but a quantum one. We have been using the wrong key. It's like trying to open an electronic lock with a mechanical key. Google's experiment was just a simulation, but it opened a new door. Maybe one day, we can use quantum entanglement to construct real wormholes. No impossible exotic matter required. While the world was focused on the quantum angle, a team led by Professor Dai-De Chang at Yangzhou University proposed a different idea in 2023. They suggested we stop trying to build wormholes in four-dimensional space-time. Instead, look higher. What if our universe is a 3D membrane in a higher dimensional space? Imagine two dots on a flat sheet of paper. They look far apart, but if you fold the paper, the two dots touch. Dai's team calculated that if two parallel universes exist, their gravity could warp the membranes. Two massive objects could pinch their respective membranes until they fuse. This creates a wormhole-like structure. They found that two objects with the mass of the Sun could, under specific conditions, form a stable channel. No exotic matter needed. This research was featured as a cover story, offering a third way to reach the stars. Do you see the pattern? The history of wormhole research is a cycle of humans being proven wrong, only to find a new way out. 1935. Einstein says they close instantly. 1988. Thorne says exotic matter can open them. 1996. Casimir proves negative energy exists but is insufficient. 2013. ER equals EPR turns the problem toward quantum entanglement. 2022. Google simulates it. 2023. The Chinese team proposes the brain world solution. Each breakthrough subverts the last. That is the true charm of science. Now, we can answer the opening question. Why did the universe bury an unusable back door? Perhaps because it's not meant for travel. It is a test. The answer to this riddle holds the secret to unifying quantum mechanics and general relativity. It holds the truth about the nature of space-time and how many dimensions actually exist. A wormhole is a mirror. It reflects the boundaries of human knowledge. It is waiting there, silently. It will only open when we truly understand the essence of time and the quantum realm. 100 years ago, black holes were a myth. In 2019, we took a picture of one. 50 years ago, gravitational waves were a joke. In 2015, LIGO caught them. Every one of Einstein's crazy predictions has been verified by time. Will the wormhole be next? Perhaps in a dimension we cannot yet see, or in a fold of higher space, wormholes truly exist. They are connecting the unreachable corners of the cosmos. The universe doesn't lie, it just saves the hardest puzzles for the end. Reality is always more magical than fiction. Our search for truth never stops. So, here is the question. If a wormhole were proven to exist tomorrow, where would you go? Would you go back to change a regret? Or jump to the future to see the fate of humanity? Tell me your answer in the comments.